we have a theorem which relates change in the kinetic energy and net work done from all surrounding objects by all forces. Mechanical energy, by definition, equals the sum of kinetic and potential. Mechanical energy cannot be changed in a system with no friction, generally in the absence of non-conservative forces, but for us it's friction. No friction, no matter what's happening, mechanical energy does not change. We know that, it's a fact. And we have several ways to make the same statement. Work kinetic energy theorem, the law of conservation of mechanical energy in general. Yeah. If friction is present, friction changes energy. Mechanical energy equals kinetic plus potential. So these are all the same statements. It's like same person, but different names or different pictures. Which to use? Normally, we choose between work kinetic energy theorem or the law of conservation of mechanical energy in the form of master equation. No matter how we solve the problem, we get exactly the same result, but there is a matter of convenience based on experience. Normally, usually, if we know that the friction is absent, no friction, the easiest way is just to write this. If we know that friction is present, in that case, I would recommend starting from work kinetic energy theorem and then doing networks term by term. This is 4 kilograms weight. So what's going to happen if I take this weight, lift it up, place a can, and let it go? Crushed. This was one of the experiments, well, similar, which eventually led to a formulation of law of conservation of mechanical energy. What's happening now? Nothing. There is difference. There is difference. So people understand the height matters because height related to speed of collision. So the question here in this experiment, very good for morning class, is mechanical energy conserved? What is happening in general? When this weight is moving up, it means potential energy being stored in it. Gravity does negative work. My hand does positive work. I'm transferring my energy to this more and more and more and more and more and more. I was doing work. Right now, no one is doing any mechanical work, no motion. So when it's released, potential energy decreases, but kinetic energy increases. So we observe the transfer of energy from potential into kinetic. Is there any friction? Because as we know, if friction is present, mechanical energy decreases. If friction is absent, mechanical energy stays the same. In this situation, there is some friction. It's small, technically negligible, but theoretically, friction here. And when the can getting crushed, squeezed, the parts of this can rub each other. So a certain amount of energy disappears to friction. Disappears in quotes. It doesn't exactly disappears. It's getting transferred into what? Well, eventually it all goes to heat. And we will learn about heat in the future.